Hey folks, Mandic Really here. Do you want to make some beautiful resin time lapses like this? Well, you're going to need to pick up a ResinLapse cable from Uncle Jesse and Andrew Sink. But if you're like me using a Panasonic GH6, you'll find out it doesn't work with your camera when you go to use it.
Never fear though.
Myself being the mad scientist of all trades, I reverse engineered that cable to work with my Lumix cameras, and I'm going to show you how you could probably do it for just about any camera on the market. Quick disclaimer, I've only tested the cable that I have produced so far with my GH5 and my GH6 cameras. Both have worked beautifully, but I can't guarantee that it's going to work on everything because I haven't tested it on everything. But I will tell you right now, some TLDR here, if you're looking to use this on a Canon camera or a Nikon camera, you're probably better off just buying the ResinLapse cable from Uncle Jesse and Andrew Sink, because this cable that I made cost me as much in materials to make as buying this cable would have cost. First things first, let's go over the parts we're going to need to do this job. The first item we're going to need is a 4-pole 2.5mm jack to go into the remote port of our camera. Now, it is vitally important that we have a 4-pole 2.5mm jack for this trigger cable. Canons use a 3-pole 2.5mm jack. Seems like maybe it would work, but it just doesn't. If you try using the Canon ResinLapse cable on a Panasonic camera, it will trigger start recording even if you're in photo mode, so you'll just film a video that starts and stops at each layer. Of course, then we're going to need wire. We don't need a full hookup kit like this. Again, we only need 2 wires, but that's what I had on hand. A single 40 kilo ohm resistor. I threw a link in the description down below to an assortment of resistors that I have here in the studio. That has a 47 kilo ohm pack in it. I used one of those. It worked perfectly fine for my needs. Some heat shrink and sleeving, whatever you want to do as far as cleaning up the final product is concerned. And the key ingredient to all of this, photoresistors. These are what's actually going to be triggered by the UV light of the resin 3D printer. You're going to want something like a GL5506 photoresistor, which should have about the proper 2 kilo ohms of resistance when triggered. Effectively, what we are creating here is just our own remote trigger cable for the camera that actuates off of light. It's going to use the UV light source in the resin printer to trigger the camera to take a photo at each exposure layer. If you're any good with wiring, I'm going to throw up a wiring diagram here and now so you can see what it is we are trying to create. I put this together from information on various blogs and posts over the years, because there was a point some years ago with like a GH4 where there were no remote trigger cables available for that camera and people had to make their own. It's pretty straightforward. We're going to use the 2 terminals, the 2 rings of the 2.5mm jack that are closest to the wire side of the pigtail. And the other 2 wires we have no use for. All we need is those 2 wires. In my case, it's green and black. It will vary on yours, so you're going to need to continuity test or check your own wiring. Overall, producing this thing is pretty straightforward, so let's get into it. So I'm going to start off by getting rid of the white and the red wire that I already said we don't need. They don't serve any purpose for what we're trying to do here, so they can just go away. Next, we got to pull out the length of wire we want for this project. I would say better safe than sorry, go longer so you can put the camera further away or at different angles or whatever without being restricted by your cable length. I just need to strip my wires so I'm ready to solder them to my pigtail. I'm going to use this little third hand here to kind of hold these wires for me because it just makes my life easier. I'll fire up the soldering iron and slip these 2 wires together and then hold them with the third hand so I can solder them. You'll notice I left these legs purposely a little bit long on this thing. The reason for that is this is where our 40 kilo ohm resistor is going to go. So I twisted the leg of the photoresistor with the legs of the 40 kilo ohm resistor, which, yes, this is not actually a 40 kilo ohm resistor. I misplaced those, and this is only a temporary cable just for this demonstration. Time to get these soldered together. Now I can trim these down to something more manageable for the wiring I'm actually going to do to our harness. The slimmer and the sleeker this is, the easier it's going to be to fit into your printer. That's one thing I can definitely say about the ResinLapse cables, is their end of their cable is really nice and sleek for fitting through like grates and vents in printers, and that is pretty handy. Now, since this is a photoresistor and a resistor, these are not diodes. The direction of current travel doesn't matter. I slipped the heat shrink up and over top of the wires, the legs of the photoresistor and the regular resistor as much as I could. I'm going to squeeze these together a little bit, get it as slim as I can get it. Then I'm going to slip a piece of heat shrink over top of all of this, leaving the photoresistor end visible so it can pick up the light source. The first one of these cables I produced, I sleeved over this with, nylon braid sleeving, and I heat shrunk it all real nice so that I had a clean looking cable, because that's the cable I intend to use for a long time. This one I just made for this demonstration, and I'm probably going to recycle it into something different after this. Probably a trigger mechanism on one of my printers using a micro switch for FDM time lapses. Let me know if you'd like to see that in the comments down below. But effectively, we have now made our ResinLapse cable. That's it. It's time to install it into the printer and see how it works. The installation principles here are basically the same for any UV curing resin 3D printer. On this particular machine, we need to get into the base so we can get to the light source of it. There's no vents around the side of it, so we have to go through the bottom. Now, careful inside of here. As with any other machine, we have the potential to damage plenty of this stuff or hurt and injure ourselves depending on electrical components that might be holding charges like capacitors and such. Now, we want to mount this cable somewhere up above the light source that's not going to be in the way of the light getting to the screen. I mean, I could just lay it on top of the light array, but then it has a chance of casting a shadow that could show up in our print and cause defects. On this particular model, I put a zip tie around the Z-axis motor and then just slipped the photoresistor into that zip tie facing down toward the light array. And that seems to be working just fine for this. Now it's time to just close this all up. And just before we test this thing out, I want to say a quick shout out to my patrons on Patreon. Thank you folks for making content like this possible. Your support directly goes towards helping make these projects happen, and I greatly appreciate it. So thank you to each and every one of you. And if you're not a member of my Patreon already, please consider checking it out. I just recently released this 3D printer nozzle can cup, holds your 12-ounce cans in there quite securely. Blizzard test. There'll be a link in the description down below so you could check it out for yourself. Now, to test the operation of this, I have the cable hooked up to the remote port on my GH5. I'm going to go into the menu system and do a test exposure. In this system, it's detection and next. And you can see a flash on the LCD screen on the camera. That was an exposure. Actually, that was an exposure in two senses. The camera took a photo exposure and the layer would have been exposed were there any resin in the vat at the time. So that's essentially what we're doing here is layer by layer, it takes a single photo per layer to then stitch together in the end for a time lapse that looks like this. Just hopefully your resin print turns out better than that failed dolphin that I put at a weird angle specifically to make it a better resin time lapse, and I let it run despite knowing that the resin print had failed. Whatever, I just wanted another time lapse to put in this video. Quick, very important note, you do want your camera in single exposure mode, not time-lapse mode. You're just taking a single photo per layer, so your camera will not be able to build a time-lapse for you as it would with the time-lapse function on the GH5 or similar cameras. So you're gonna need to post-process and do all of that stuff yourself. There are plenty of tutorials on how to do that. Let me know if you want me to show you how I do it. I've been using a program called LR Timelapse lately, which I've really been liking for making really high quality time lapses. I mentioned at the beginning of this video that I was going to tell folks who had other camera brands how they could do this. What I'm going to do is I'm going to throw a link in the description and a comment down below to a website that has breakdowns of how to wire up remote trigger cables for various camera brands, whether they use like proprietary plugs, the Canon plug with only 3 poles on it, various options on the market. They've got a great breakdown of a bunch of them. I use some of the information from that website for my project here. I had to pull information from a couple sources. All right, folks, that's going to wrap it up for this one. I hope you found this video interesting. If you did, please drop the video a like. It really helps out. Let me know in the comments. Are you going to make one of these cables for yourself? What are you thinking after watching this video? Get subscribed for more maker content like this and beyond. Thanks for coming around, folks.